Imagine you are drifting through the pitch-black void of interstellar space, trillions of miles from the nearest star. Suddenly, the stars behind you begin to warp and stretch, swirling into a distorted circle like a malevolent drain in the fabric of the night. You don't see a solid object, but rather a sphere of absolute nothingness, rimmed by a thin, ghostly halo of light. You have just encountered a rogue black hole, a cosmic predator that has been wandering the galaxy in total silence for billions of years. There is no warning, no heat, and no sound. By the time you notice the gravitational tug, your fate is already sealed by the laws of general relativity. Most people think of black holes as distant, static anchors at the centers of galaxies, but the reality calculated by modern astrophysics is far more unsettling. From invisible wanderers stalking our solar system to primordial microscopic singularities that could be drifting through your very house right now, the scenarios involving these gravitational titans represent the ultimate limit of physical terror. We are going to explore the most bone-chilling black hole scenarios ever put to paper by scientists, from the spaghettification of entire star systems to the horrifying possibility that our entire universe is trapped inside one. If you thought space was a cold, empty place, wait until you see what happens when gravity decides to break the rules of reality itself. Let's start with the scenario that keeps planetary scientists awake at night. The rogue wanderer. We used to believe that black holes stayed where they were born, usually at the center of a collapsed massive star or at the heart of a galaxy. But we now know that when two black holes merge, the resulting gravitational waves can act like a rocket engine, kicking the new, larger black hole out of its home at millions of miles per hour. Scientists estimate there could be millions of these homeless black holes roaming the Milky Way. Because they aren't surrounded by glowing gas or devouring a nearby star, they are practically invisible. If one of these were to enter our solar system, we wouldn't see it coming until it started tugging on the orbits of the outer planets. It wouldn't even have to hit the Earth to end our civilization. Just by passing through the Oort cloud, it would send millions of comets screaming toward the inner solar system. As it moved closer, its gravity would rip the Earth out of its stable orbit, either flinging us into the freezing depths of interstellar space or dragging us toward the sun. We would be helpless passengers on a planet losing its grip on stability, watching the constellations twist into nightmare shapes as the invisible giant passed by. But what if the black hole isn't giant? This leads us to the second terrifying scenario: primordial black holes. According to Stephen Hawking and other theorists, the Big Bang was so violent and dense that it might have crushed pockets of matter into tiny black holes the size of an atom but with the mass of a mountain. These things would be virtually indestructible and could be zipping through space like cosmic bullets. There is a fringe but mathematically sound theory that one of these microscopic monsters could pass directly through a planet. Because it is so small and moving so fast, it wouldn't swallow the Earth, but it would leave a microscopic tunnel of absolute destruction through the core. The heat generated by its passage would create a global earthquake of unprecedented magnitude. Some researchers have even suggested that Planet 9, the mysterious object hinted at by the orbits of distant Kuiper Belt objects, might not be a planet at all, but a primordial black hole the size of a grapefruit orbiting our sun. We could be living in a solar system with a dark, ancient singularity as a neighbor, and we would have no way of knowing until we sent a probe directly to its coordinates. Now let's talk about the actual process of entering a black hole, specifically the firewall paradox. For decades, we believed that if you fell into a large enough black hole, you wouldn't feel much at first as you crossed the event horizon. This is the no-drama zone of general relativity. But in 2012, a group of physicists calculated something that contradicts everything we thought we knew. They argued that due to quantum entanglement effects, the event horizon isn't a silent curtain, but a literal wall of high-energy particles, a firewall. Instead of drifting peacefully into the dark, you would be instantaneously vaporized the moment you touch the edge. This creates a massive problem for physics because it suggests that either Einstein was wrong or quantum mechanics is incomplete. For an observer, it means the boundary of a black hole is a region of infinite heat where the laws of biology and chemistry are deleted in a Planck second. It turns the gateway to another world into a cosmic incinerator. The fourth scenario involves the intergalactic vampire, or the binary siphon. Imagine a black hole orbiting a normal star, like our sun. The black hole's gravity is so intense that it begins to peel the outer layers of the star away, creating a bridge of screaming, superheated plasma. As the gas spirals into the black hole, it accelerates to near the speed of light, heating up to millions of degrees and emitting lethal X-rays and gamma radiation. If you were on a planet orbiting that star, you wouldn't be swallowed by the black hole. You would be fried by the star's own blood. The radiation would strip away your atmosphere and boil the oceans long before the black hole finished its meal. This accretion disk becomes one of the brightest and most lethal environments in the universe, a spinning whirlpool of light that marks the slow consumption of an entire solar system. This brings us to the fifth and perhaps most mind-bending scenario: the end-of-time transition within a rotating black hole. Most black holes spin, and the math of a Kerr black hole, a rotating one, suggests that inside the event horizon, space and time swap places. In our normal world, you have freedom of movement in space but are a prisoner of time, always moving toward the future. Inside a black hole, the mathematics suggest your future is a physical location, the singularity. You can no longer move away from the center any more than you can move away from tomorrow. But in a spinning black hole, it's even weirder. Centrifugal forces might prevent the singularity from being a point, turning it into a ring singularity. If you could somehow navigate through the center of that ring, the math suggests you might emerge into a white hole or another universe entirely. But the cost is total isolation. You could never return, and the tidal forces would likely shred your atoms into a one-dimensional stream of matter before you ever saw the other side. You would be a ghost in a new universe, with no way to tell the old one what you found. For those interested in the space economy and long-term finance, black holes represent the ultimate stranded asset. In the far future, as stars burn out, black holes will be the only sources of energy left in the universe. Scientists have proposed the Penrose process, a way for a future civilization to scavenge energy from a rotating black hole by throwing matter into its ergosphere and catching the resulting energy boost. This would be the ultimate green energy, total conversion of mass to energy. However, the market risk is literal. If your energy harvesting station drifts an inch too close, your entire corporate headquarters and all its employees are lost to the singularity. In a black hole economy, there is no such thing as an insurance policy. The margin call is at the speed of light, and the liquidation is absolute. The sheer scale of power involved would make our current global economy look like a child's lemonade stand. But the stakes would be the literal deletion of the investors. The sixth scenario is the great attrition or Hawking radiation decay. We used to think black holes were eternal, but Stephen Hawking proved they leak energy over unimaginable spans of time, 10 followed by 100 years. Even the largest black holes will eventually evaporate. The terrifying part is the final pop. In the last seconds of a black hole's life, it releases its remaining mass as a massive burst of gamma radiation. If a microscopic primordial black hole were to finish evaporating while passing through our solar system, it would go off like a multi-megaton nuclear bomb without any radioactive fallout. Just pure, raw energy. This means that even the safest black holes are actually slow-motion time bombs, ticking away in the darkness until they reach their explosive conclusion. The seventh and perhaps most existential scenario is the holographic shell, or the naked singularity. Usually, singularities are hidden behind the event horizon, the cosmic sensor that protects us from seeing the point where physics breaks down. But some calculations suggest that under extreme conditions, a black hole could spin so fast or be so distorted that the event horizon disappears, leaving a naked singularity exposed to the universe. If you were to look at a naked singularity, you would be seeing the literal end of physics. Causality would break down. You could see an effect before its cause. The predictability of the universe would vanish. Such an object would be a glitch in reality, a place where anything and everything could happen without reason. Scientists are terrified of this because it would mean the universe is fundamentally irrational. It would be like finding a hole in a computer game where you can see the raw code, and that code is screaming. Let's look at the spaghettification of a human being. It's a term that sounds funny until you realize the physics. Because gravity gets stronger the closer you are to the source. If you fall feet first into a stellar mass black hole, the pull on your feet is millions of times stronger than the pull on your head. Your body wouldn't just be crushed. It would be stretched into a thin, miles-long strand of atoms. Your heart would be miles away from your brain long before you died. Because of time dilation, to an outside observer, you would appear to slow down and freeze at the event horizon, turning redder and redder until you faded away. But in your own frame of reference, you would see the entire history of the universe speed up and pass by in a flash as you plummeted toward the center. You would witness the birth and collapse of galaxies in the seconds before your atoms were torn apart. You would be the ultimate witness to the end of time, but you would be too stretched out to tell anyone. Now consider the supermassive collision. At the center of almost every galaxy sits a monster with the mass of billions of suns. When galaxies collide, these monsters eventually find each other. They dance in a gravitational waltz that sends ripples through the fabric of space-time, gravitational waves. These waves are so powerful they physically stretch and compress the space they travel through. If you were close to two merging supermassive black holes, your very DNA would be stretched and squeezed as the space you occupy distorted. The energy released in the final merger is more than the light of all the stars in the observable universe combined, but it is released entirely in dark gravitational energy. It is a silent explosion that can shake the foundations of the cosmos, repositioning stars and determining the fate of 100 billion solar systems. What if our entire universe is inside a black hole? This is a legitimate mathematical theory called black hole cosmology. It suggests that every time a singularity is formed, a new baby universe expands out of it in another dimension. This would mean that the Big Bang was actually the formation of a black hole in a parent universe. We wouldn't know because we are trapped inside the event horizon. This would explain why our universe is expanding. It's just the internal space of the black hole growing as it swallows more matter from the outside. In this scenario, we aren't the masters of our destiny. We are just the contents of a cosmic waste bin in a higher dimensional world. The dark energy we see might just be the gravitational tug of the parent universe pulling on our bubble. It makes us feel very small, but it also provides a weird kind of comfort. We are part of an infinite chain of creation, a fractal of singularities. The financial prepping for a black hole scenario would be impossible, but the information economy around them is already huge. Companies and universities spend billions on projects like the Event Horizon Telescope, which gave us the first image of a black hole's shadow. Why? Because the person who solves the information paradox, or finds a way to reconcile gravity with quantum mechanics, will hold the key to the ultimate technology. If we can understand how a black hole compresses space, we might find the secret to warp drives or wormholes. Control over gravity is the ultimate monopoly. It would allow for the movement of goods and people across the stars instantly. Currently, space travel is limited by the Tsiolkovsky rocket equation. Fuel is heavy, and you need fuel to carry fuel. But gravity-based propulsion would bypass this entirely. The black hole gold rush is already happening in the minds of the world's best physicists, even if the physical gold is trillions of miles away. Consider the Stalker black hole in a triple star system. Many stars in our galaxy come in groups of 3. If one of those stars becomes a black hole, it can remain in a stable, quiet orbit for billions of years. But eventually, the other 2 stars will age and expand. The black hole will begin to feast. For any civilizations living on planets in that system, they would have grown up with 2 suns and a dark spot in the sky that they thought was just a curiosity. Then, over a few centuries, their dark spot starts to glow with the light of 1,000 suns as it begins to devour the neighbor. The safe neighborhood becomes a war zone. This teaches us that stability in space is always temporary. We live in a brief window of calm in a universe that is fundamentally violent and hungry. Is there any defense? Can we shield against a black hole? The answer, according to current physics, is no. Gravity is the only force that cannot be shielded. You can block X-rays with lead, you can block magnetic fields with superconductors, but you cannot block gravity. If a black hole is coming for you, it doesn't matter if you hide behind a planet or a star, its tug will find you. The only defense is distance. This makes the mapping of our local gravity neighborhood the most important survival task for future generations. We need to find every rogue wanderer and every primordial singularity within 100 light-years before they find us. We are currently blind to most of them. Our telescopes look for light, but we need better gravity telescopes to see the shadows. Let's talk about the slingshot effect. If a black hole passes through a galaxy, it acts like a gravitational scythe. It doesn't have to swallow anything to cause chaos. It takes stars and flings them out of the galaxy into the intergalactic void. These hypervelocity stars are moving so fast they will never return. If a sun with planets is scythed this way, The planets might be ripped away from their sun, or the sun might be moved so far from its planetary family that they freeze. A black hole is the ultimate homewrecker. It leaves behind a trail of cold, dark, and lonely worlds. We see these rogue planets drifting in space, and many of them might be the refugees of a black hole encounter billions of years ago. We are the lucky ones who are still in a stable orbit, but the scythe is always out there, somewhere in the dark. The coldest place in the universe is actually just outside a black hole's event horizon. While the accretion disk is millions of degrees, the black hole itself is incredibly cold, just a fraction of a degree above absolute zero. If you were in a ship near a quiet black hole, you would have the ultimate heat sink. This is why future civilizations might huddle around them. They are the perfect places to run giant computers because you can radiate away the waste heat into the black hole. A black hole could power a Matryoshka brain, a computer the size of a solar system that could simulate billions of virtual worlds. In the very end, humanity, or our robotic descendants, might become black hole dwellers, living in the frozen, distorted space around a singularity because it's the only place where the laws of thermodynamics still allow for work to be done. It's a bleak but strangely hopeful vision of the end of the universe. A civilization clinging to the edge of the abyss, using the last drops of gravity to keep their digital dreams alive. Why is the no-hair theorem terrifying? It states that a black hole only has three properties: mass, charge, and spin. Everything else, the history of the star it was, the composition of the planets it swallowed, the DNA of the people it vaporized, is deleted. To the rest of the universe, it's all just mass. A black hole is the ultimate eraser. If you fall in, your entire existence is reduced to a single number added to the black hole's weight. There is no monument, no record, and no way to recover your information. This loss of history is what makes black holes the ultimate villains of the cosmos. They don't just take your life, they take your legacy. This is why the fight over the information paradox is so intense. Scientists are fighting to prove that the universe has a memory, that history cannot be truly deleted. If they lose that fight, then the universe is a place where things can truly not matter anymore. Imagine a black hole cluster. In the dense centers of globular clusters, hundreds of stellar mass black holes can gather in a gravitational swarm. They don't merge immediately, they sort of buzz around each other like angry bees. If a planet were trapped in such a cluster, the sky would be a kaleidoscopic nightmare. Every few years, a black hole would pass close enough to cause massive tides, pulling the oceans up miles into the air. The radiation from multiple accretion disks would flicker in the sky like a broken neon sign. It would be a world of constant, unpredictable change, where the very ground beneath your feet could be liquefied by a passing shadow. It is a miracle that our sun is in a quiet, boring part of the galaxy. We live in the cosmic suburbs, far away from the inner city where the singularities play. As we move toward the year 2026 and the next generation of space observatories, our understanding of these monsters will only grow. We are planning missions like LISA, a giant gravitational wave observatory in space, that will be able to hear the smallest black holes merging. We are effectively building a gravity radar for the galaxy. This will be the first time we can see the dark side of our neighborhood. It's a time of great excitement, but also great humility. The more we learn about black holes, the more we realize how powerful and indifferent they are. They are the architects of the universe, shaping galaxies and determining the flow of time itself. So the next time you look at a photograph of the night sky, don't just see the stars. See the gaps between them. Think about the invisible wanderers, the microscopic bullets, and the spinning ring singularities that might be out there. Black holes are the ultimate boundary of our knowledge, the place where our math screams and our physics breaks. They are terrifying, yes, but they are also the most profound things in existence. They are the anchors of reality and the erasers of history. They are the end of everything and potentially the beginning of something new. Stay curious, stay humble, and remember, in a universe ruled by gravity, the black hole is king. We are just guests in its kingdom, trying our best to understand the rules before the shadows move a little closer. The sky isn't empty, it's full of secrets, and some of those secrets have the mass of a billion suns. Keep looking up, but never forget the power of the dark.